Right. Okay, now we have discussed this already. Now you know the purpose of this program. And again, like we're gonna start from the very beginning, right? And then there are little Oracle certifications also available. Then you could try out what are the available certifications you could do, right? And we discuss about this, what is Java, and then you know Java is a software platform and it is a programming language which is widely used technology. That's why you have selected Java. Right now, this was invented by James Gosling in 1995, and this was initially developed by Sun Microsystems, but now it is acquired by Oracle Corporation. And nowadays, we can find JDK 21 with the regular update release and also the long-term support release also JDK 21. Right, right. Then the evolution of Java, then as we previously discussed that Java released 1.0 in 1995, right? Now you have Java 21, right? The JDK 21, right? And when it comes to Java, then when you install Java, that means you can see some differences. Java runtime environment and Java development kit like then yes. In order to do the coding, here we require Java development kit. In order to do the coding, we require the Java development kit. That's why I asked you to at the beginning open the command prompt and type Java C and check whether the command is there or not. Right, then whether the Java is installed on your computer or not, or if not, you need to install Java development kit into your computer. It doesn't matter what is the operating system you are using, you have to install Java into your computer. Right, now initially Java was invented by James Gosling in 1994, right? And he was originally, this was named as Oak, and this was a part of the Green project at Sun company, and the green project goal is to make consumer electronic devices communicate with each other using special programming. Then as a result, Java was invented, and initially this was called as Oak, right? And then when you're talking about Java, then you may have heard about C and C++. Then by that time Java was invented, there were widely C and C++ available. Then as a competitor for C and C++, Java had many advantages. Some of the advantages are C and C++ entirely depending on the pointers, but in Java there is no point. Then what is the point? Yes. Java pointer means, right, in order to access certain locations, certain variables, you need to access the memory locations. For that, there are pointers used. In Java also, any programming language require pointers. Then pointers are very important part of the language. But in Java, all the pointers are handled by the language, therefore not by the programmer. In other languages, the programmer has to handle the pointers. Since Java handles the pointers, therefore programmer no need to handle the pointers. Therefore, Gosling has omitted pointers entirely from Java. And then the reasons to make the Java become so popular was platform independent, and it is a powerful language, and it is secure, it has higher performance, and the networking. Right now, what do you mean by platform independent? Can someone tell me how Java is platform independent? How Java is platform independent? Can someone tell? Yes, can someone tell me?
It means that the bytecode compile can run on any operating system.
The bytecode compile can run on any computer. Right, yes. Now, yes, there's another reason we discussed last. Java virtual machine. Can remember that part. Okay. Now, the reason is like now when you install Java, like now when you take a computer, sometimes that won't run. Okay, if you want to do the development, right, then you need to install Java. Then installing Java means what? We do install Java virtual machine into our computer. Therefore, whatever the code we are writing is not get converted. The source code we are writing, the Java code we are writing, we call as the source code. Then the source code we write not get converted to the machine code directly. As you said, it get converted to the byte code. Then byte code. What do you mean by byte code? Yes, it get converted according to the Java virtual machine architecture. Then since it works according to the Java virtual machine, right, therefore whenever you use Java, that means when you install Java, that means you are installing Java virtual machine, right? That means whenever you have Java, that means you have the Java virtual machine. Therefore, everywhere you have the same virtual machine there. Then you can easily run whatever the compiled code, whatever the bytecode you have now, you can run on any computer easily because whenever you install, you have installed the Java virtual machine and the bytecode you got that is converted according to the Java virtual machine. Therefore, that will work on any computer. Right. And then, yes, powerful language. Yes, we'll discuss. Right. Now, then Java has some security features we call as sandbox. Then it checks for the array boundaries, and then we will discuss in this later on how it works. Okay, now this also you can understand. Now, when the Java version upgrades, the number of classes it supports increases, and the efficiency of the code get increases. Likewise, then now we have Java 2.21. Right now, this is how the versions released. JDK1, which is called as OAK, and 1.1, 1.2, 1.3, 1.4. Then thereafter it became 5.0. Then that we call as 1.6 version. And Java 6, Java 7, Java 8, Java 9, Java 10. Then up to Java like 8 was called as 1.8. Thereafter Java 9 version was Java 9. And thereafter now we are having JDK 21, Java SC 21. The version is 21, which was released in 2023. Right. Right. Now these are the things you need to remember now. Java architecture. Right. Java architecture comes with 4 separate but intertwined technologies. Now these are called as Java language, Java class file, then Java API, and the Java virtual machine. Right. What is a Java programming language? That is what we are about to learn. Java programming language, that means all the codes we have written, source programs are written using the Java programming language. Then as we discussed, Java codes starting with the Java classes, all the codes resides inside Java class, and all the procedural code falls within methods. Programs are compiled into a Java, that means bytecodes or the class files. Classes runs in the Java virtual machine. When a program runs, it is assisted by the other classes in the Java using the Java application programming interface. Right. Therefore, basically, you need to know, okay, there are some all the codes we write using the Java programming language. Java programming language. Now there are variables, methods, and classes, like as we discussed. You have variables and methods are inside the class, and there are certain rules. Every statement should have a semicolon. Likewise. Then once you compile, once you compile, you can right. It will get converted to a bytecode. That's what you call as the class file. And then the class files are running on the Java virtual computer, virtual machine, and then with the support of the other classes. Right. Now, how this works? Right. We write the source, okay, and then we compile using the Java compiler. The Java compiler convert that into a class file, which is the bytecode. Then the class file feed into the Java virtual machine. Then the Java virtual machine, with the help of Java API, API stands for Application Programming Interface, right? With the help of API, it loads the necessary classes in order to run this one. Right? In our case, right now, what was the class we had? Right, we were right. What we wrote. Right. Now this is the code we wrote. Public static void main. Inside this, we call this particular method string dot system dot out dot println. Okay, now println is a method. When we run our file with the help of Java API, it will load this print method, that println method. It will open it with the help of API, it will load the necessary method. Right. Likewise, this is how it's gonna work. And then it will release the output. Right. This is what basically happens in our program. Right. We write the source code, we compile, and then it generates the bytecode. Bytecode feed into the Java virtual machine with the help of Java API. JVM will release the output. Right. Now, what is the bytecode? Now, then, in contrast to the conventional programming languages, right? Compared to the other programming languages, Java program is not compiled into machine language. Remember, Java is not compiled into machine language, but it compiled into a bytecode. Therefore, bytecode is a result of Java compiler. That is low-level code similar to machine language, which is similar to the machine language, but not the machine language. Because it is generic, because it is not specific to a particular processor, because the bytecode generated according to the Java virtual machine. Right. Then bytecode is feed into the Java virtual machine. Right. Now, what is the Java virtual machine? We discussed this. Java virtual machine is a software-only subcomputer within the operating system, which converts the bytecode, whatever code we have written into a bytecode. Right. Okay, then let me try. Okay, we'll see. Right. Now, initially, what happens? Okay, now we write our code using the Java language. Okay, now we have the Java programming language. We have the test.java. And then once we compile, we get test.class. Right now that is this test.class. Now this is the bytecode. Right now this is what has happened right now using uh, we compile, and now when you compile the test file, test.java, it created a test.class. Now that is what you call as a bytecode. Now bytecode is what? Bytecode is not the machine code, but is similar to the machine code. Why? Bytecode, like machine code means when you convert a source code into a machine code, that is not generic. That will be converted according to a particular processor. But in Java, when you convert into a bytecode, like now that will work. That get compiled according to the Java virtual machine. Therefore, it will be generic and not specific, but similar to the machine code, which will be a very low level code. And then this bytecode has to be feed into a Java virtual machine. Therefore, now this anywhere wherever you have a Java virtual machine, you can feed this. You can feed this bytecode, and then this bytecode has to be interpreted. Now this is the bytecode. This can be interpreted. Therefore, whenever you run the Java program, every time you run, it get interpreted by the Java virtual machine. Since the bytecode, the source code converted to the bytecode, then the bytecode means which the virtual machine understands. And the virtual machine using the interpreter interprets line by line of this bytecode. And then we get the output. Right now, in order to do this, right now, the process you can remember now. We have the source code, we compile, we got the bytecode. The bytecode we feed into the Java virtual machine. Right. And then we discuss that the bytecode is not the machine language, but it is similar to the machine language, and it is a low level code because it is generic and not specific. Generic and not specific to any particular process, because that is according to the Java virtual machine. And then we have to feed the bytecode to the Java virtual machine. And Java virtual machine is a software only subcomputer, which is a virtual machine. And then within the operating system that converts a bytecode into the machine language and executes. That is interpreted. Therefore, JVM is platform dependent. So there are different JVMs for each OS. Now that is why when you download JDK, you selected Java for Windows, Java for macOS, Java for Linux, likewise you select. Why? Because that is platform dependent. Because it has to communicate with the host operating system. And JVM, right, has multiple that will supports for multiple platforms, therefore platform dependent. Therefore, bytecode communicate with the Java virtual machine, and the Java virtual machine talking in the operating system. See, we feed the bytecode to the JVM. Now JVM communicate with the operating system, and then we get the output. Now this is what happens. On the host operating system, we install the JVM, and then we feed our bytecode to the JVM with the help of Java API. It loads the necessary classes which required to execute this particular Java class, and then output is communicated to the host operating system. That's how we see the output. And then the Java API. API stands for Application Programming Interface. Now this is the set of classes and interfaces which comes with the Java Runtime Environment. JRE stands for Java Runtime Environment. Java Runtime Environment is a huge collection of library routines which performs basic programming tasks, looping, displaying, sorting, likewise. Then here in our case also, we use this system.out.println method. Now this is a method available in the system package. We use this println, right? Then here, since we are using a predefined methods, right? Likewise, when the version upgrades, the multiple whatever the classes, availability of the libraries and classes become more high, then therefore, in order to perform certain activities, we could just call rather writing. Right now, here also there are a huge collection of library routines which perform the basic tasks. Right now, we are using this print method. That's how we use the API. Now, therefore, because of the JVM and the bytecode, whenever you run your program, every time you run, it gets interpreted. Therefore, that's why you say compile once or the write once, run anytime on anywhere, wherever you have Java. Yes, you need to compile once. Once you compile, it get compiled, it get converted to a bytecode. And then you can feed the bytecode into the Java virtual machine, and Java virtual machine will interpret every time you runs. That's how the JVM works. Right. Therefore, you compile and then you have the bytecode. You can run the bytecode on any computer in Windows, Mac, or Unix because it doesn't matter the file compiled on Windows or the file compiled on Mac or file compiled on Unix. It doesn't matter. You could run on anywhere because our source code gets compiled according to the JVM. Now, if we have installed Java, that means we have installed Java Virtual Machine as well. Right. Therefore, it is platform independent. Right. And we have two type of Java files. You can have console-based applications as well as GUI-based applications, graphical user interfaces as well as console. Right now, here we'll be using console-based applications. Right now, we'll be using console-based applications as well as in after some weeks, we'll be dealing with graphical user interfaces as well. Right. Then when you talk about the architecture, Java platform is unique because it can work without modification on any platform, on any operating system, if that operating system or if the platform has a Java virtual machine. Okay, remember Java platform is unique because it can work without any modification on any platform, on any operating system, if that platform has Java virtual machine installed. Okay, can someone tell me why, how we can run Java class, whatever the Java files on any platform without doing any modification? How can you do that?
So by installing JRE,
By installing JRE,
Java runtime environment.
JDK, right? Yes. Now the answer is okay. Why? Okay. Now the platform is unique because it can work without modification on any platform. Why? Because of we are installing Java virtual machine. Because right, the basically now this is what you need to remember. Like we have Linux, we have Mac, we have Windows. The way they work totally different. But it doesn't matter right now, even though let's say this is a Windows and this is Linux and this is Mac. And on top of this, we're gonna install what? On top of this, we're gonna install we're gonna install JDK for this JV. Okay, now what happens now? Let's say now this is Windows. This is Windows and this is Mac, and then this is Linux. Then we download JDK for Windows. We have JVM. Now this is what we did. Right now we have on top of we have the same. Therefore, like we have the same. Now we have the same environment now. Everywhere we have the same environment. Therefore, now this is the same. Therefore, whatever the file we have here, you could run on this one or here, anywhere, because now we have the same environment. Therefore, this let's say this is the bytecode converted the code into a Java virtual machine. Therefore, we could run our bytecode on any platform wherever we have JVM. Is that clear? Is this clear?
Yes, sir.
Right? Is this clear? Hope this is clear. If it is not, please ask.
Yes, clear, sir.
Right. Then, yes, now that is why we can say write once run anywhere. If someone asks why you say write once run anywhere, okay, what do you mean? Okay, write once run anytime. What do you mean by that? Write once run anytime. Okay, why would you say write once run anytime? How? Can anyone try? Anyone? Do you have any idea? Why? Please try out. Because why? Can you quickly try?
Because having the JVM, it can run on any hardware.
Because first we convert it to what? Once we write the program, we convert it to what?
Bytecode.
We can okay. We write and we convert it to a
Bytecode.
bytecode, right? When we compile, what happens? That you need to remember. What happens? We have the source code. Then what happens?
It converts to machine code.
Not the machine code to the bytecode, right?
Byte.
Yes. Yes, bytecode. It gets converted to the bytecode. And thereafter, after you feed the bytecode, what happens? Now remember, now we have the bytecode, and then bytecode means what? The class one, and the bytecode can be feed into the JVM, and every time it feed, it get converted. It freshly interprets. It interprets. Therefore, Java virtual machine converts the bytecode to the machine code and give us the output. Therefore, it interprets the code. Therefore, every time that's why we say write once or compile once. If you have the tag compile once, yes, we are compiling only one time. We compile only one time. We convert it to the bytecode only one time. Thereafter, the bytecode can be interpreted. Every time you run, it get interpreted. Therefore, we compile once and run multiple times. And we could run on any platform as well with respect to this JVM. Okay, is this clear? Right. Okay, the primary goals is to have the code portability, the speed of the development. Likewise, then code portability is achieved by using the bytecode. Like, and then here the IDEs I discussed. We have NetBeans, Eclipse, JPato, JDeveloper, IntelliJ, likewise. And when it comes to Java, You can see that there are different versions, Java SE, Java EE, Java ME, Java FX likewise. Then we are talking about Java Standard Edition. That is for the desktop-based applications, right? Then we have Enterprise Edition, Micro Edition, and FX for the rich internet applications. Right. Now, thereafter, we discussed about how to write the basic Java program last time. Okay, this is what we discussed last day. Right. Now, we're going to start with the today's work. Right. Now, what we have to discuss is, right. Any questions up to now? Do you have any?